Okay, so we've been learning about the derivative. We've been talking about just recently critical points. Okay, when we first learned critical points, I just talked about them as being horizontal tangents, or where the slope is zero, or where the slope of the tangent line is zero. Now we start talking about critical points. And to find critical points is where you find where the slope is zero. You find the derivative, set it equal to zero, those are where your critical points lie. Okay. Now we're going to be using the first derivative test to actually test those critical points and see if they are truly maximums, minimums, or neither. Okay. So the first thing we have to do is find our critical points. So to find critical points, you take the derivative and then set it equal to zero. So the derivative 9x squared plus 18x. Then we take our derivative and we set it equal to zero. Now we have to find the solutions, the zeros of this. To find solutions, we factor. So the greatest common factor is 9x. We take out 9x. We're left with x plus 2. So our critical points are when x is equal to 0 and when x is equal to negative 2. So now that we have our critical points, we're now going to set up a first derivative test. So basically what a first derivative test is a number line. You're going to put your zeros on your number line, like so. The next thing we're going to do is we're going to test our slopes to find out if they are positive or if they're negative. So this is a first derivative test. So that means that we're plugging in values and testing our first derivative, hence the name. So I'm going to pick a number on this side of negative 2, like negative 3. And I'm going to plug it into my derivative and see if my value is positive or negative. Now the easiest way of doing this is plugging it into your factored form. So when I plug it into my factored form, I get negative 3 times 9, positive 9, which is a negative number. And then negative 3 plus 2 is negative 1. So negative times a negative is positive. Okay? So this is telling me that on the left side of negative 2, my slope is positive. And that's telling me my function there is increasing. Okay? Next, I'm going to plug in a number in between negative 2 and 0, like negative 1. When I plug in negative 1, I get negative 9 times positive 1, which is a negative number. Okay, so there my slope is negative. And on the other side, I'm going to plug in positive 1. And when I plug in positive 1, I'm going to get 9 plus times positive 3, which is going to be a positive number. Okay? So now what we're going to do is we're going to use this test to determine what's going on at my critical point. So I have this critical point sitting right here at negative 2. On the left side, my function is increasing, so it's going like this up to my critical point. On the right side, it's decreasing because my slope is negative. So my function here at negative 2 is going increasing to decreasing, which means at negative 2, this is a maximum. Now at 0, again, here's my critical point. On the left side, though, this time it's decreasing since my slope is negative. So my function is decreasing, going down to 0. But on the right side, my function is increasing. So it starts to increase after here. Okay. Now remember, at this point, the slope is 0. It's a horizontal tangent. Negative 2 and 0 are horizontal tangents. But 0 is a minimum because it goes down and then back up. This is how you use the first derivative test to tell if these critical points are maximums, minimums, or neither. Okay? It's just like that. Now, we're also supposed to check to see critical points where our function is undefined as well. Okay? Because that could be a maximum minimum as well. So let's look at something like this. Find the maximum minimums of a rational function. Now, basically we're doing the exact same thing. So first we need to find the derivative, f prime of x. Okay? I'm going to use quotient rule. So it's the low function times the derivative. Nope, the other way. It's low d high minus high times the derivative of low all over low squared. Okay? Now we will need to simplify this a little bit. So 2x times x squared is 2x squared minus 2x minus 2x squared plus 2x, like that, all over x squared minus 1 squared. And then we got 2x squared minus 2x squared, which is 0, and then negative 2x minus another 2x, which is negative 4x over x squared minus 1 squared. So this is my derivative, simplified, f prime of x. Now, in a rational function, what we learned in pre-cal, to find zeros of the rational function, they come from my numerator. So when we set this equal to 0, we're basically just setting negative 4x equal to 0. Because whenever the numerator is 0, the whole thing is 0. So that's when x is 0. But our critical points also come from where our function is undefined. And in a rational function, it's where the denominator is 0. That's where our function is undefined. So I also have to set x squared minus 1 equal to 0, which means x squared equals plus, sorry, let's just go straight to the end. Well, x squared equals 1, x equals plus or minus 1. So I have 3 critical points. So here we go. Now the difference on this one is when I plug in 0, that is a 0, but at negative 1, my function is undefined, and at positive 1, my function is undefined. Where my derivative is. And we do exactly the same thing we did the last time. We're just plugging in numbers. So here I'm going to plug in negative 2. Now the bottom will always be positive, because it doesn't matter what I plug in for x, I'm then going to square it, which is going to be positive. So the only thing that's going to change my function's my derivative is the numerator, this negative 4x. Because if I plug in a negative number here, it's going to become positive. Then you're going to subtract 1. Even if that's negative, once you square it, it'll be positive. So negative 4 times negative 2, this is positive here. Then like plug in negative 1/2. Positive here, positive 1/2. That's negative, and plug in 2, and that's negative. Okay? So here, it goes from positive to positive, okay, which means that there is no, it's neither. Because only when it changes sign do we get maximums or minimum values. So here it goes from increasing to decreasing. So this is a maximum at 0. And that's where our maximum is. We have one maximum. That's the first derivative test. Find your critical points, put them on the number line, test your first derivative to find out if your derivative is positive or negative. Where it changes sign, that's where you have maximums and minimums. That is the first derivative test.